Hello, this is Dr. Ross. I would like to do another video for shortest path algorithm using Dijkstra's method. So let's go and get started. First of all, I just go to our Blackboard page, and here I will download 6 case edges data dash 2 CSV file. So let's download that. And then once you download that file, I would just open that file and I will start making changes on this file to build my model. So here you can see that we have from and to nodes. So you can see nodes start from 1 and all the way go up to 12, and each edge connecting these nodes have different costs, as you can see here. So first of all, I would like to save as an Excel file so that I can make some changes and put some formulas in it. Save as. And I will say instead of data, I would just delete the data, so it's not going to be data file anymore. Um, so I would just save as an Excel file. Okay. Now, what I would like to do is build a model based on this data. So I will just create a model section here. And as you guys know, I just like to put in general my model on the right side, then keep the data on the left side. Click on this column D to change the color of this, let's say to light blue. And I will Control B to bold it. And I would like to use, let's say, a red color here. The first step for any prescriptive analytics model is to define the objective. And here, these are costs. So cost is something that's bad. So I want to minimize bad things, minimize cost. And I like to use green cell for my objective. And then second step is my decision variables. And in this case, I have several decision variables, which are each decision variable is associated with each of these edges. So what I'm going to do is I will just copy this, Control C, Control V. And then my decision variables will be shipments, number of shipments for each of those edges. I will highlight this area and I will put I like to use yellow cells. So you can see we have um, 21 different decision variables. Perfect. So we defined our objective, we defined our decision variables. Now the third step is to determine our constraints. So for the constraints, what I would like to do is I will place them, I can place them in different places, but let's say I put them right here, step number 3. Decision variables, sorry, constraints. So I will put subject to. And constraints have left-hand side and right-hand side values. So let's start with first of all, let's label them because I have several constraints. And here I have 12 different nodes. So I will put all those nodes right here. I tab 1, 2, I highlighted those numbers and drag it on until I see 12. Control S to save it. So these are my nodes. I can just put them here, my nodes. And then I have my edges right here. Maybe I'll just Control B, edges. So the first edge I can see here is 1 to 2. So I will just put, instead of 1 to 2, I will put 1, 2, which is from 1 to 2. And second edge, you can see 1 to 3, and then 1 to 4, and then 2 to 5, and then 2 to 6, and 3 to 6, and 4 to 6, and next edge is 4 to 7, next edge is 4 to 9, next edge is 5 to 6, and 5 to 8, and 5 to 9, and 6 to 9, sorry, 6 from 6 to 9. And then we have 7 to 9. Then we have 7 to 10. Then we have 8 to 11. Then we have 9 to 11. And then we have 9 to 12. And we have 10 to 11. And then we have 10 to 12. And finally, we have 11 to 12. These are all the edges. Okay, so now I would like to do build my coefficients matrix here, and I like to use red color for this, so I will just use this area as red. Okay, so you can see here that 1 to 2, there's this flow from 1 to 2, so there should be 1. And there's a flow from 1 to 3, that's flow 1, 2, 1 to 4, 1, 2. That means that there is a edge from 1 to those nodes. That's perfect. And then here, my left-hand side value of the constraint versus my right-hand side value of the constraint, and calculate it as, so I need to multiply, right-hand side should be 1. Why? Because um, I want to make sure that there is a flow from 1 out, because that's the first node, because we are trying to start from 1 and reach to 12. So I want to have outflow from 1, net outflow. That's good. And then here I will do matrix multiplication of the first array are the decision variables, comma, my coefficients. Okay. So we have an issue here. The reason is that this matrix right here is 21, and here is we have only we have 21 as well. So this is 21 by 1 matrix, and it's 1 by 21. So we should be able to multiply these values, but let's just try again. So let's try to do coefficients first, and then decision variables. Okay, so basically this is not working because matrix multiplication seems like um, not working. Let's try again. Okay, so if that happens, what we can do is basically we can make these shipments horizontal as well. Control C, right click, paste special values and transpose it, and click OK. So now we have the same decision variables horizontally, which is perfect. What we are going to do is just put it right here. And I will just eliminate these yellow cells. And I will make these cells as yellow. Now we should be able to do the sum product instead of matrix multiplication. some product of my decision variables, comma, the first row. Okay, that's perfect. The reason the previous one didn't work is that because it was 21 by 1 matrix, we tried to multiply by 1 by 21. So that should be 21 by 21. So that's the problem. But you can see that we can, when we put it horizontally, it works. So now what I would like to do is maybe I will just carry these up a little bit so that there's not so much gap between those values. And again, I will just Control C, Control V, track here, and I don't need to have these delete. Okay, so now we want to have outflow from node 1 to these, you can see all these edges. Okay, so now for node 2, we have outflow from 2 to 5 and 2 to 6. That means that 2 to 5 and 2 to 6 is outflow. So I should have a negative number. And I will have here, right here, 1 to 2, edge 1 to 2 as negative, sorry, positive 1. That means that I will have inflow to 2 from 1, and I will have outflow from 2. So when I have inflow and outflow, based on these values right here, these are all the outflows, and these are this is the only inflow. So inflow, I put it plus 1 and outflows for negative 1. So what I would like to do is this is not a final destination, so all the inflows and outflows should be equal. So that means that I should have 0 at the end over here. So all these constants will be equality constants. That's why I click on it, right down corner, black cross, just drag it down. So what I can do is basically here again the sum product trick. But to be able to do that, I want red array to follow me, but the blue array to just stay there with the decision variables. I highlight that and I press F4 or some computers function F4 to lock that array and drag it down. So you can see that right now we have one flow. I just put a random example from 1 to 2, and right now this constraint is violated because there's flow to 2, but there's no outflow from 2, so that's a problem. So basically solver will fix that problem. That's perfect. So now I will go to the next node, which is node number 3, and number 3 has a inflow from 1 only. You can see it here. So that means a 1 3 edge right here is going to be plus 1, and I have outflow number 3 from number 3 to only 6. So number 6 will be 3 to 6 will be negative 1. And again, I want this right hand side value to be 0. So I want all the right hand side values to be 0 except I would like to have the number 12 as 1. Okay. Okay, perfect. Um, so I think if this is confusing you a little bit because the first one is probably, I think it's better to put it instead of ones, like here because the outflows. Why don't we just put negative ones? I think that's even better, like terminology wise. So basically all its outflows negative ones. So right hand side is negative 1. So that what does that mean? That means I want to have outflow from the first node, and I want to have inflow to the last node. Everything else, they are just hubs, and I want to have 0 balance, meaning that all the inflows should be equal to outflows. Okay, so let's go to number 4. So number 4 has outflows to 6, 7, and 9. 6, 7, and 9 right here. These numbers should be negative because these are outflows. And inflow to 4 is only coming from 1. So I should put right here a 1. Next one, number 5, has outflow to 6, 8, and 9. 6, 8, and 9 right here should be -1. 6, 8, and 9. And how can I get to 5? There's only one way, which is from 2. So 2 to 5 should be right here, should be 1. Okay. Again, inflow should be equal to these three outflows. That's perfect. Let's go to number 6. Again, I will do next video Python code of this. And as you can see, the Excel can get really, really complicated, even for a small problem like this. Imagine having a bigger problem. Okay. Question note number 6. I have outflow to 9. That means the 6 to 9 is -1, and there's inflow from 2 and 3 to sorry 2, 3, and 4 to 6. So 2, 3, and 4. 2, 3, and 4. Let's see. 2, 6, 1, 3, 6, 1 inflow, and 4, 6, 1. Okay, that's perfect. Next one is 7. 7 is outflow to 9 and 10. These values should be -1. And inflow, how can I get to 7? You can see there's only one way, which is from 4. So 4 to 7 should be +1. Okay, let's do 8. So for 8, we have outflow to 11. So 8 to 11 should be -1. And how can I get to 8? Basically from 5. So what I'm gonna do is 5 to 8. 5 to 8 right here is +1. Perfect. And then next one is 9. So 9 has outflow to 11 and 12. Those numbers are -1. And to get to 9, I have inflow from 6. So 6 to 9 edge right here should be 1. Let's go to 10. So from 10, I have outflow of 11 and 12 potentially. 11, -1. 12 is -1. And to get to 10, there's only one inflow from 7. So 7 to 10 should be +1. 11, I have outflow to 12. So there should be -1. And to how can I get to 11? From 8 and 9 and 10. 8, 9, and 10. I hope we don't have any typos. 8, 9, and 10. So this is +1 inflow, 9 and 10. Perfect. And final 12, there is no outflow, so there's no -1. Inflow, we can do from 10, 11, or 9. 9, 10, sorry, 7 also as well. 7, 10. One more time. Let's take a look at the number 12. I'm getting confused because again, it's getting hard with Excel. It's even small problem like that. So 10, 11, 9 as well. So 9 to 12, 10 to 12, and 11, 12. 9, 10, and 11. 9, 10, and 11. So 9 to 12 right here. 11 to 12 and 10 to 12 should be 1. Perfect. So now what I can do is I need to calculate the objective function value. And the objective function value is nothing more than, I'm trying to minimize cost, some product of my coefficients, which are the cost values right here, right? Again, so here I will have another issue because this is a 21 by 1 matrix. So I don't want to multiply that way. So instead, I can probably try to multiply by 11 by 21 matrix by 21 by 1. So let's try that to see whether it works. Otherwise, we will just make transpose again. Matrix multiplication. And this is decision variables 21 by 1 matrix right here. 1 by 21 matrix, I'm sorry, 1 row, 21 columns, comma, 21 by 1 matrix of cost right here. I hope this will work. Uh, so it doesn't work for whatever reason. Um, so what I'm gonna do is again, instead of having this, I will have the costs right is a transpose. I think that's going to be easier. Sorry for the mistake, but again, analytics is like this, right? You need to just figure out how to solve this problem. Control C, and then I will right click here, paste special, and here I would like to do the values and transpose and click OK. And what I need to do is the objective. I'm just going to use some product formula, and I will use my costs, comma, and my decision variables right here. Perfect. So that works. So now I would like to solve this problem. Data, solver. Again, if you don't have solver, you just click on File, Options, and then you will see here add-ins, and then you will click on the solver add-in or analysis tool pack. That's fine as well, either or, and click on Go and make sure solver add-in is checked, and then click OK, and it will take a few seconds. Once you finish that, data, solver. And then here my objective is the green cell, which is minimizing the cost. And I'm trying to minimize right here. And then I will highlight my decision variables. These yellow cells, I have 21 edges. I'm trying to figure out the transportation or shipment amounts. And I will add the constraints. Since all the constraints have the same relationship, I can add them in one step. These are the left-hand side values. I want these values to be enter equal to right-hand side values, which are right here. Okay, so this is linear programming, so choose linear programming, and all the shipments should be non-negative. So that's why this is checked. Click solve, click OK. So the best solution is the 8. And to be able to do that, what we need to do is send products from 1 to 2, that's the shortest path, and then 2 to 6, and then 69, and finally from 9 to 12. So that's the shortest path, which will give us the lowest cost. Again, as you can see in analytics, we just try different things to make sure it works. And again, Dijkstra's algorithm in Excel Solver is possible, but it's quite painful. Until next video, enjoy business analytics.